This is Quideo 3 basic question. It gives us a chart about the most popular colors for cars made in North America in 2000. Question A asks about the probability that the car you chose has any other color than the 6 listed. So I added the 6 values together and then took that number, subtracted it from 1, and found that it was 0.295 or 29.5%. Part B asks, what is the probability that a randomly chosen vehicle is either silver or white? So I added the values for silver and white together, 0.176 and 0.172, which adds together as 0.348 or 34.8%. Question C asks, when choosing 2 vehicles at random, what is the probability that both are silver or both are white? So for each one respectively, I multiplied it by itself. So 0.176 squared equals 0.0310 or 3.1%, and then for white it is 0.172 squared equals 0.0296 or 2.96%. This is the advanced question, which proposes that taking antioxidants helps prevent colon cancer. Question A asks for the explanatory and response variable. The explanatory variable is the antioxidants. The response variable is the colon cancer. Question B asks us to outline the design of the experiment, and that is that 864 people are split into 4 groups. One takes the daily beta-carotene, another takes daily C and E vitamins, another takes all 3 daily, and the last is a placebo. Question C asks us to assign 5 subjects to the beta-carotene group. Using table B at 118, I found 73, 90, 25, 30, and 47. Question D proposes that the experiment is double-blind and asks us what this means. This means that neither the patients nor those administrating the drugs know if the medicine given is a placebo or not. Question E asks us if there are any variables that could explain the results other than eating lots of fruits and vegetables. And I found that people who eat fruits and vegetables tend to be more active, which may help counteract colon cancer. This is the advanced question, which proposes that 2 antibiotics are available as treatment for a common ear infection in children. Antibiotic A can effectively treat the infection 60% of the time and costs $50. Antibiotic B is known to cure the infection 90% of the time and costs $80. These antibiotics work independently of another and can be administered together safely, and the health insurance company provides 2 different plans. The first one will administer antibiotic A first, and then if it does not work, it will follow with antibiotic B, and then plan 2 will treat with antibiotic B first, and then if it's not effective, then treat with antibiotic A. Question A asks what the probability that each plan will work, and I found that each would work at a 96% probability. Question B asks what the cost of each plan is, and if each plan requires the second treatment, then it will each cost $130, whereas if both work at the first treatment, then plan 1 would be cheaper at $50 rather than plan 2 at $80. Question C asks which one I would recommend. And I would recommend plan 2 as it is more likely to work the first time, and this means that it's more likely to be cheaper as you would only have to pay for the first dosage.